In this video, we're going to be taking a look at how to solve absolute value equations. And so we already know one way that we could solve any equation, and that is that if I can make a graph of it, then I can solve it. In this sort of a case, what I'd be trying to graph is basically y equals the absolute value of x plus 3. If I can graph that, then I can figure out when it equals 10. So I'm going to go ahead and graph that. I know it's absolute value, therefore it's a V-shaped graph. And the plus 3 tells me that it's been shifted up 3 units. So I know that's my graph. Now, in order to solve it, I need to figure out where does the whole thing equal 10. Normally it would be all equal to y, right? But since it's not equal to y, it's equal to 10, that must mean that y equals 10. Well, where does y equal 10? Well, y equals 10 up here, but it also equals 10. The y coordinate is 10 everywhere across that line. And so that dotted line there represents where my y coordinate is 10. Now I can just look at that graph and be able to tell what my solutions are. And notice I'm saying solutions, plural, because there are in fact two different places where my graph hits a y value of 10. And we're going to have to include both of those. And so the first one, the coordinates of this point are at negative 7, 10. And the second one, the coordinates are at 7, 10. Now when I'm solving my equation over here, I'm trying to figure out what x is. So in my answer, I'm only going to say what x equals. So for that first point on the left side, that would mean it equals negative 7. And for the second point on the right side, that would mean x could also equal a positive 7. I'm going to go ahead and just put a comma between them in order to list them out. But please be very careful. Notice I am not putting parentheses around that. If I put parentheses around the negative 7 and the 7 like that, then all of a sudden it's a coordinate pair where one of them's x and one of them's y. We don't want that. We want both of them to be the x. And so leave off the parentheses there so that we are just listing multiple answers. The trouble with this particular method, even though it got us to the right answer, is that it does mean that in order to do it, we have to make a graph every single time. And that's going to be a bit problematic if our solution is not at a nice, pretty whole number too. And so what we're going to really start digging into now is how would I get to that same conclusion algebraically? So again, back to the same start. And of course, one thing I can see algebraically that I can do right at the start is I could move that 3 to the other side. We could subtract 3 from both sides. And yes, in this case, we can still do that. So I go ahead and I subtract 3 from both sides. Now I have the absolute value of x equals 7. This is the new bit. This is the tricky bit. Because the absolute value of what equals 7? Well, the absolute value of 7 equals 7. But the absolute value of what other number would also equal 7? Remember that absolute value takes whatever it is inside and makes it positive? So the absolute value of negative 7 would also be 7. Which is why then we again can see why we end up with two different solutions. Here x does equal negative 7 and 7, just like we saw from our graph. The trick is that we need to remember that when we are doing this algebraically, when we get rid of those absolute value bars, we have to account for both the positive and the negative solutions on the other side. So now we go on to a new example. And in each of these problems that we do, your first step will always be the same. And that is to get whatever the absolute value is, to get that part by itself, which in this case you can see means that we're going to have to be getting rid of the 6 and the minus 4. How we do so follows all the same rules that we've always used when solving equations as if it was just an x. And so the first thing we want to do is get rid of the addition subtraction. So I'm going to add the 4 to both sides and then divide both sides by the 6. Now I have 4 equals the absolute value of x. And now we have to get rid of the absolute value bars. And so, using what we just learned in the last example, when I get rid of the absolute value bars, I have to account for both the positive and negative solutions. And therefore, x here can equal -4 and +4. Go ahead and just list them out with a comma in between them. And then we head on to our next problem, and you notice in this case, the +5 is inside of the absolute value. That actually does change some things, because I cannot just start by subtracting 5 from both sides. This doesn't work, because right now that +5 is taking place inside of the absolute value, and order of operations says that I would have to do x plus 5 before I took the absolute value. And so if I'm undoing it, I have to get rid of the absolute value before I can get rid of the +5. So that means I got to get rid of the absolute value. In order to get rid of the absolute value then, as we've talked about, we have to account for both the positive and the negative solutions. So x plus 5 here could either equal -9 or 9. And now I can start figuring out what x is, right? But in order to do that, as you might expect, we're going to have to subtract 5 from both sides. But how do I subtract 5 from -9 and 9? That looks kind of weird, right? Having both numbers just sitting there together. So when you hit this type of situation, what I'm going to have you do is actually split this whole thing into two separate equations. Make it x plus 5 equals 9 and x plus 5 equals -9, because that's what that means when we list out both answers. It means it can equal 9 or -9. So now that they're written both as two separate equations, I now can solve each of those two separate equations fairly efficiently. So when we subtract 5 from both sides, for one of them we get x equals 4, and for the other one we get x equals -14. And notice, these are not just opposites of each other. When the first one was 4, that did not make the other one -4, because that +5 is on the inside of the absolute value, and it makes all of the difference in the world for it being there instead of on the outside. And now we come to the very last problem that we're going to work through together in this video. And so we're going to be solving this one for x. Now you've actually already seen all of the individual pieces that we're going to be going through, but we haven't put them all together into one big problem like this. But it still would be well worthwhile to try working this problem on your own first before you watch me go through it. So I would recommend that you pause the video right now, solve it, and then press play again once you have your solution. All right, so what I want to do here is I want to start by getting the absolute value by itself. So that means I want to get this absolute value of x minus 9 all on its own there on the right-hand side, which means getting rid of the 2 and the -5. In order to get rid of those, I do want to get rid of the subtraction first. So I add the 5 to both sides, and then I can divide both sides by 2. Having done that, I now have the absolute value by itself, which means I can now get rid of the absolute value bars. In order to do so, remember we have to account for both the positive and the negative. And so I split it up into the two equations. I don't just list it with a comma here because I do have to do a little bit more work to move that 9 over. But now that we are at this point, we can go ahead and move that 9 to the other side. So I add 9 to both sides of the equation. And so I end up here with answers of 15 and 3, which you can see it's written as two separate answers here. You could also format your final answer by writing it like this. That means the exact same thing.